Welcome. Today we start the phase 2 of the ProxyMind. And if any one of you wondering who's phase 2, what's ProxyMind, you must check out my video in the channel. Okay. Now, as we discussed earlier, the phase 2 will include the LangGraph orchestration. What does that mean? That means that we are going to implement LangGraph in our ProxyMind to make it work. Like the agent, it will not be just backend then, and it will become an agent after we implement LangGraph in ProxyMind, right? So, most of you must be wondering why we are using LangGraph and not LangChain. To tell you that, or to give you a correct perspective about why I am using LangGraph and not LangChain, you must understand the difference between the both. So LangChain, it's an open source library. We all know it's an open source library which is used or which is created to simplify our process if we are building any LLM based application, large language model. ठीक है and its core components, although it's really basic components आते हैं model, prompt and retrieval. ठीक है then what does these components means? So model, it provides an interface through which we can access any of the LLM out there. Like we can switch between any of the LLM, like there's Entropy, then there is OpenAI, then there's Gawk. So we can switch between any AI without writing the whole set of code again and again. We can just switch using the interface. Good. Why not we are using LangChain? There's another component. There's a driver and then there is prompt. Prompt help us engineers to they tell suggestions, they give suggestions, they tell stuff in advance like plan and everything, which we tell about transformer. It gives suggestions and plan everything based on your course of work, what you do, right? Good enough. Why not LLM? Well, I mean, why not LangChain? Why LangGraph? Now, what is LangGraph? LangGraph is a framework that is based upon the LangChain. That means it is the upgraded version of LangGraph. But LangChain is still good. Why? How? LangChain is like if we are making a basic chatbot, then we must go for LangChain. You're making a basic chatbot, or like you can say, summarize, like for summary to summarizing tool, you can use LangChain. But to understand why particularly LangGraph for this ProxyMind, I have prepared a whole chart. After that, I can make sure that you'll understand and you'll say like, yeah, why are we using LangGraph? I prepared for you guys that LangChain and LangGraph comparison, if we say about it. And if you want the chart, I provided the link in the description. You can access it anytime, it's free. Okay, so the most important thing, why we are using LangGraph, why not we are using LangChain? So just recall, what is ProxyMind all about? ProxyMind will provide you the persistent memory so that it can remember us, right? The last 7 days. So we need a complex system. But if we go with LangChain doesn't support whole loop-like system. See, here it is written that some struggles with complex multi-step logic, workaround like LLC and frictions. So basically, it doesn't support like a whole loop system. It doesn't support loop system. In order to write loops in LangChain, we have to use glue code. Glue code is basically the normal Python in which we are using loops, for loop, while loop, whatever loop you want to use, you can use. But we use it in the form of the glue code, and it is said that use the less glue code, the better your code will be. So for that reason, our ProxyMind will have complexities much more than this. We can't use LangChain here, right? So we are using LangGraph because it handles complex problems really well. That's why. The second and most important thing is state management. So our LangChain is is not good with state management. Why? Because state is basically a key value pairs, right? And LangChain doesn't support key value pair. It doesn't have anywhere to store key value pairs. Whereas if we talk about LangGraph, it has a proper state object where it stores the state and allow all the node to access it from anywhere. So it became a really good flow. Here it is written, defined a type state flow object. Every node can read and write to share state, making data flow transparent and predictable. That's why the third point is event driven. Event driven. So what does this mean? Our LangChain is sequence driven. That means LangChain is linear. It works in linear flow. Like you send the prompt, it go to LLM, then it send the prompt, then it again go to LLM. So like this, it thinks also like this in sequence. It's sequence driven. It will not break its sequence. It will not depend upon if that prompt or that event required to stop, it will not stop. If it stops anywhere, it will again start from the starting. We don't want that. We don't want our model, to break in between. That's why. And if we talk about LangGraph, it has a custom, like it basically have, it's a stateful of, it's that is stateful. So what do I mean by that stateful? It stores event and allow it to work really well. It basically works according to event. If event required to stop, it will stop. If event required to go, it will go. It is written. Nodes can conditionally route based on the state. According to state, it can go all over around. Okay. Supports checkpoint, meaning the graph can pause, react to events, and resume to any point. LangGraph have checkpoints. Checkpoints basically are stored where it can store its current event, current situation, and it can resume from it anytime. The fourth point is fault tolerance. Fault tolerance, that means like if a model is working, if by mistake or anything it has an error and it has something it can't solve on its own, right? So if that kind of thing happens in your model, then LangChain will not stop and think what's going wrong. No, it will again start from the starting and it will erase all the data. We don't want that, right? So we are using LangGraph. Why? Because it basically have a custom thing, have a built-in fault tolerance. And it basically have two types, which is short term and long term. Here it is written short fault and major fault. It is also called short level and large term, anything. So for short, if we have like short fault, it can refresh it on its own. See, retries from the exact failed node, like wherever, because LangGraph is like a graph and it have nodes in it. So it retries again and again. If this, like suppose here it's wrong and here the fault is, so this thing will retry here. It will not go here again. No, if it come to here, it will retry this node again and again. And if a large fault or we can say major fault, then we have checkpoints. It will resume, it will store that state in the checkpoint and then solve the system and then again resume from that checkpoint. The next thing we have is the human in the loop. So what is human in the loop? So many times it happens that whenever model you give some prompt, model is working, and suddenly, like if you are a manager, you want to hire someone, you hired them, you tell your tool, your model, to send the email to this and this recruiter telling them the offer. If they accept it, then appoint them. If they didn't accept, we will change the offer, right? Well and good. Then you send the offer to them. Now you have to wait for human response. For human response, you have to wait, right? Unless and until that interviewer, the one who's giving interview looking for a job, unless and until that person says yes or send you an email saying yes or click on yes, doesn't accept your offer, you can't respond to the manager. The model can't respond to the manager that this person said accepted the order and is ready to work. So here, model have to wait unless and until the human response. So if we talk about LangChain, LangChain can't wait. No, here it is written. Not designed to pause or wait for human input. Long wait hours and days are unsupported. The chain will time out or fail. Whereas if we talk about the LangGraph, can halt execution at any node and wait independently for human response. It can wait. It can pause its execution and can wait because it have event driven thing. So it can wait. The last thing is nested workflow. What is nested workflow? Nested workflow is like nested loop. Nested array, you must have heard about nested array, nested loop. So it's like nested workflow. LangChain doesn't support this. Like nested workflow, like suppose we have one some command here. For example, some command here. So model giving command, then coming to this command again, then giving command, and coming to this command again, then again giving output and coming to this command, like approaching the same thing again and again, just like function. Let's say if we are using multiple same function again and again, just like that. So the LangChain, if we talk about nested workflow, so how can we do nested workflow? It is not even driven, it fault tolerance. It doesn't support complexity, so we can't do nested workflow in that. But if we talk about the LangGraph, we can for surely do the nested because it have a built-in functionality which is subgraph we can do. So this clearly explains to you why I am choosing LangGraph and not LangChain, because we want a complex model. Our ProxyMind is complex enough. So we want something to handle that kind of complexity, right? So that's why we are using LangGraph, not LangChain. And if you have any query, anything, write down in the comment section and I'll make it one. See you in the next video, maybe the implementation, or you can say about the agentic AI, whatever topic you want.